Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at group 6 elements, which are going to form a part of the P block of elements, which we are going to be having as part of our discussion for this topic of a comparative study of S and P block elements. Now, the group 6 elements are going to consist of these members of oxygen, sulfur, selenium, beryllium, polonium and livermorium. And of course, we are going to create emphasis on the first four elements, which I'm going to mention the reason for that. Now, in terms of our classification, the first three elements, particularly the first two of oxygen, sulfur, are going to be, of course, non-metallic elements. But we're going to see that in terms of these specific characteristics, we're going to see particularly for the element of tellurium is going to exploit this or display these metallic and non-metallic characters, and therefore it's going to be classified as a metalloid in this specific group. Now the element of polonium is going to be or is just a metallic element, but we're going to see that due to its specific characteristics of being radioactive, we're going to see that particularly its uses are going to be limited in this particular case. Now in our illustrations and various discussion which are going to follow this, I'm going to be using some specific examples, and of course particularly the reaction of various members of this particular group, which is going to be forming a range of compounds from ionic to covalent compounds, as we are going to see. But of emphasis in this discussion, I'm going to create a contrast between the two which find wide application, especially for oxygen and sulfur. And that's going to form a final bit of this specific discussion. So as I've said, the group 6 members are going to form a range of members from oxygen, and that one is going to be sulfur, selenium, and then we're going to have this member of tellurium, and then lastly we're going to have this particular member of polonium given in that specific case. So we're going to look at these specific members, perhaps in terms of some of them which are going to have some similarities, and then we're going to look at their classification in terms of the various sections which we have mentioned for metals, non-metals, and metalloids. And in this particular case, I said that basically we're going to have these specific members, especially for the first three members, which are going to be either classified as other metals and non-metallic members, especially for the first two groups or first two elements of oxygen and sulfur. And these are going to be shown in their specific, of course, characteristics in terms of reaction or physical characteristics. So this is going to be oxygen, perhaps if I may mention them in terms of names, so that we can just have a follow of what these members we are discussing. And this is going to be tellurium. And the last one we're going to have is polonium. So we have mentioned the last member in some of our discussion on the topics of radioactivity, and of course that was one of the compounds which were found by the curious, and as I've said, we're going to see that it's going to have a limited use in terms of its application. Now for the first two members of oxygen and sulfur, we're going to see that these members are going to react with the metals to form ionic compounds. So they are going to react with metals to form what we refer to as ionic compounds in this specific case. So we can give an example of this one. If we have a sodium reacting with oxygen, so this is going to form a sodium oxide, which basically is going to be ionic. So we can give another example of a metal reacting with this specific member of sulfur. This is going to lead to the formation of a potassium sulfide, and these two specific compounds are going to be ionic in nature. So the reaction between oxygen and the first two members, or metals with the first two members of this group, are going to form ionic compounds given as such. So if we look at perhaps the reaction between these two specific members plus non-metallic members or non-metals, these are going to form what we refer to as covalent compounds. And we can give an example of this. If we have a hydrogen, of course, reacting with the oxygen, this is going to lead to the formation of a water or two molecules of water given as such. So we shall have that one given as such. So this is going to be the same case, if we have a hydrogen reacting with sulfur, this is going to form hydrogen sulfide. So these two molecules are going to be covalent compounds given as such, and that is going to create a contrast between these first two members of the, or rather a similarity between these two members of the group for the reaction between these members and the metals and non-metals. So they are going to create ionic compounds and covalent compounds in that specific respect. So in terms of the difference of their compounds which are being formed for oxygen and sulfur, we're going to see that most of the compounds which are formed by oxygen, or most important compound that is going to be formed by this specific combination of oxygen and other compounds is going to be, so this is going to be oxygen in combination with other compounds. So the most important element that is going to be formed from the reaction of oxygen and other compounds is water, and of course this is going to be given as that. And in this specific case, the most important compound that we're going to come across that is going to be realized from the reaction of sulfur and other, of course, elements is going to be hydrogen sulfide. And there's going to be a difference between the two in terms of their compounds, in a sense that water is going to have a higher melting point compared to hydrogen sulfide. And this is due to the presence of hydrogen bonding or hydrogen bonds which are going to be present in this water molecule and lacking in hydrogen sulfide, and that is going to create a contrast between these two most important compounds, or the two most important compounds of oxygen and sulfur in terms of their differences. Now, I said that basically this discussion is going to be also emphasizing on the similarities and difference between oxygen and sulfur. And this is because these two specific elements in terms of their elemental form and compounds are going to form a basic or essential part of our day-to-day application. So therefore I'm going to have this specific difference between the two, so that in case we come across them, we are able to distinguish between their various applications in terms of element form and the compounds. So I've said basically that the two elements for the first one of oxygen is going to be a gas at room temperature and pressure. So perhaps I can quote this. This is 298 kelvins and at 1 atmosphere. So because of space, I'm going to mention this one as a room temperature and pressure, whereas this one, the other one, is going to be a yellow solid at room temperature and pressure. So that's going to create a contrast between the two elements. And this is going to have two forms of allotropes. For oxygen, we're going to have this one as diatomic molecules and a triatomic molecule given as such. Now for sulfur, these are going to have two basic allotropes of rhombic and monoclinic sulfur. And this, in terms of course, appearance, is going to be in forms of many molecules in terms of perhaps liquids and gaseous forms, and we're going to see that that's going to be creating a difference between the two. Now, in terms of oxidation, this is going to have a wide range of oxidation states, and for oxygen, it's going to have oxidation states ranging from -2 to -1, and then we shall have 0, and of course negative half in some of the of course, states we are going to have like this one. And for the sulfur one, we are going to see that this is going to be having oxidation forms ranging from -2 to +6, given as such. So that's going to create a contrast between elemental oxygen and sulfur being shown as such. And this is going to form ionic oxides with metals, just like the specific two equations which I've given in my previous statement, and so that's going to create a difference between. So this is going to form ionic oxides with metals, but of course this is going to form ionic sulfides with the specifically active metals, and then they are going to form covalent compounds or partially covalent ones with other metals. So with active metals, it's going to form ionic sulfides, but with the rest of the metals, that's going to form what we refer to as partial covalent compounds given as such. So this is going to hydrolyze to form water. So from our previous equation, this was of course the case. So it's going to hydrolyze. The reaction between hydrogen and oxygen is going to form water. But of course, this one is going to hydrolyze and in water to form. So this specific state is going to hydrolyze in water to form hydrogen. So this specific form of an ion, and of course the hydroxide ions are given as such. And oxygen is in most of the compounds, oxygen is not going to be. So we're going to have this one as not the central. So it's not going to appear as the central atom in most of the compounds, and this is going to be more elaborate in our study of complex compounds. So in this case, it's not going to appear as a central atom, but for sulfur, this is going to form a central atom in most of the compounds which we are going to come across. And in this case, it can form up to or accommodate structures of up to 6 given as such. So we have said about the concept of catenation, but we're going to see the difference, especially in our study of complex compounds. But this is going to create a difference between the two for formation of structures, especially where oxygen is not going to be the central atom, where sulfur is going to be the central atom in that specific case. Now, the carbonates of oxygen are going to be reacting with the sodium hydroxide to form carbonates, but the forms of sulfur carbides is going to be, or the carbonates of sulfur are going to be reacting with sodium hydroxide to form a range of compounds. Now, we're going to look at that one in our separate video, especially on carbon, the reaction of carbon and sulfur. And that's going to create a contrast between the two. So kindly check our description boxes for various links of other videos. Now, this has not been a comprehensive one, but of course in the comparison between oxygen and sulfur, this is going to create a basis for us in trying to interpret some of the reactions which we are going to come across in our various discussions. So that is it for now, guys. Bye, God bless you. Catch us in our next video.